So yesterday we attempted to do something on worksheet 12 and we ran out of time right at the end of class, right? Okay. So what I'm going to actually do is start on 11 and then when it makes sense, I'm going to switch back and try to finish that question that we were working on yesterday. Can I hit the light switch closest to the call button for me? Thank you. All right, so linear programming is what this is called, and we do optimization problems. Okay, many applications in business and economics involve optimization, the process of finding a maximum value or a minimum value for a specific quantity. When the quantity to be optimized is represented by linear graphs, it's just called linear programming. Two-dimensional linear program consists of a linear function to be optimized, called the objective function, and a system of linear inequalities called constraints, and then you will get a set of systems or a feasible region. Okay, so yesterday we were talking about this question. Let me go back over this. Okay, bakery box, remember this question? Okay, so the constraints were our inequalities. All right. We said we only had so much dough, we only had so much icing, and we only had so much time. And every time we made a box of plain cookies, it took a certain amount of each of those things. And every time we made a box of iced cookies, it took a certain amount of each of those things. Then we graphed those inequalities along with discussing the fact that things couldn't be negative. We can't make negative cookies. So we had to be in the first quadrant. And we largely graphed the inequalities by using their intercepts, 0 for x and 0 for y, rather than solving for y. Okay. And then to find where they intersected, that's where we got a little rush. Okay. We want all, after we've shaded, we want all the corner points of this, what's called the feasible region, right? So 0, 0, 0, 50, 60, 0, those were easy to find. But to find these other two intersection points, okay, you can use your calculator and graph the lines and find the point of intersection. You could say, well, this is where the purple and green line intersect, so I'm going to type the purple and green equations in as a matrix and find their point of intersection, okay? You could do substitution, which is actually what we did when we wanted to find where the green line crossed the purple line, because we knew all the points on the green line had y equals 50, so we just substituted it into the purple to find the point of intersection. Once we have all the points on the corners of the bounded feasible region here, this is where we got totally off track because we were rushing. This is what's called the objective function on the notes we were just looking at. Okay, this is at the bottom of 12b. Okay, so suppose the profit, you don't have the types, you just have it says extra down there. Okay, a little frustrated with my cursor as usual. There we go. All right, suppose the profit on each box of plain cookies is $2. So we make $2 per box of plain cookies, and iced cookies is $3 per box. That's the objective function, and what we are trying to do is maximize the profit. Sometimes the objective function is cost, and then we want to minimize the cost. Does that make sense? All right. What we have to do is list all those corner points. Can anybody tell me? There was 0, 0, what else? Oh, no. Okay, and 0, 50, is that right then? Okay, and what? No, it can't go up that high because it has to stay below the red and below the purple. Okay, so don't want all the intersections. We just want the ones that are bounded by the purple here. All right, so what are we missing on our list? 30, 40, and 15 something? 1550, was that right, guys? Okay. Then we're supposed to put each of those in here to evaluate what the profit would be. If we made no cookies, we'd get no money. If we made only iced cookies, what would we get? Yes, does everyone see what we're doing? We're putting into here. So 2 times 0 plus 3 times 50 equals 150. Can I not write that out for every problem? Do you get what I'm doing? Okay, so 2 times 30 plus 3 times 40 is 180. And it so happens that this one also came out 180. Okay? Most of the time there's only one. On the quiz, there's only 1 point that maximizes the profit. On this particular one, either one of these would work. So Jack and Jill make the most profit if they make 30 boxes of plain and 40 of iced, or 15 of plain and 50 of iced. It just so happens that there's 2 points that have the same. On the quiz, there'll only be one. So they could either use another constraint to decide which of those was a better plan, or maybe Jack says, you know, I'm not feeling the iced cookies today, so let's go 30-40 because then I can leave 30 of them plain instead of having to ice quite so many, whatever. All right. That's our, back to this, okay? The vocabulary, the objective function, what we wanted to maximize or minimize at the end. The constraints were the inequalities, and the feasible solution were all the corner points. So we have this theorem that says if a linear programming problem can be optimized, its optimal value will occur at one of the vertices, okay? So it's always at one of those vertices. The steps we're going to use are we're going to write the system of inequalities. We're going to graph and shade, find all the corner points, and then plug all those corner points into our objective function. Yep, you got to be able to write the objective function, write the constraints, graph. All of this is on the quiz. We did break it down into little pieces, okay, so that you don't get double punished if you mess something up. This is problem number 1. How do I graph this one? I'll do this one in green. If you want colored pencils, there's some in the back of the room. We could put the zeros in, or could we solve that one for y pretty easy? This is worksheet 13, 12, 11. Thanks, guys. Okay, if I get the y by itself, it'll say y is less than or equal to negative 2x plus 20. Does that seem right? Or plus 10? Yikes. Okay, so if I go down 2 over 1, down 2 and over 1, it should cross down here. Everybody good for the green line? Okay. Above or below? It was a less than or equal to, so my feasible region is below there. Okay. These last 2 constraints just mean I'm in the first quadrant, right, guys? Okay. Got to be above the x-axis and to the right of the y-axis. All right, do you want to solve this one for y, or can I do it the other method? If you put a 0 in, it'll now say 2y equals 8, which would make y 4. If I put the 0 in for the y value, it would just say x is 8. So over 0 and up 4, over 8 and up 0. Above or below? It was, if you put in the 0.00 just to check, right, you'd get, it works, so we're down this way. All right, so the place that those intersect and is double shaded is this little box down here. Okay, we can't use this intercept here. We can't use any of these points up here. We can only use the ones bounding this little shaded area. So what are the corner points of that feasible region? 5, 0. Good job. Over 5 and up 0. I always have to say it so I don't get them backwards. It looks like 4, 2. We should check that one in a minute. What else? Over 0 but up 4, right? And over 0 and up 0. Okay. So how do we check that 4, 2 is working? Yeah, we could plug it. It should work in both of these. Or we could have typed in our calculator this and done RREF to see if it came out 4, 2. Or we could have done a little substitution or elimination, any of those. Since we think we know it, I'm just going to check it. It'll be 2 times 4 is 8, plus 2 is 10. 4 plus 2 times 2, which would be 4 plus 4 is 8. It's beautiful. It's working. Okay. Now, it says in the directions, what we are to do is to find the maximum and minimum values of this objective function up here. We didn't graph this because this is the function we're trying to maximize or minimize. So I don't have a lot of room. I'm going to write them over here. 0, 4, 4, 2, 5, 0, and 0, 0. Okay, if I put them into that function, into function f, which is 3x minus 2y, what happens when I put in 0, 4? 3 times 0 minus 2 times 4 would be, okay. If I put in 4, 2, I have 3 times 4 is 12 minus 2 times 2, which is 4. 12 minus 4 is 8. Do I need to be writing out the work, or are you getting what we're doing here? We're putting them in here. So 3 times 5 minus 2 times 0 would be 15. And 3 times 0 minus 2 times 0 would be 0. Okay, where was the maximum? Okay, so at 5, 0, we had a maximum of 15. And it also asked us to find the minimum. Where was the minimum? Yeah, it wasn't 0, 4. It was actually, or 0, 0, I mean, it was actually 0, 4 because we'd be in the whole 8. Yes. No, you would interpret them if it was a word problem, but no, that's it. Now, you got to be careful. What I do on the quiz, guys, just because it says maximum value of, and then it says occurs at, so you would have written maximum value of 15, and it occurs at 5, 0. Is everybody okay with what I'm saying? That you need both of those pieces of information, but I made that very clear on the quiz. This one also wanted minimum, but moving on. Number 2. Okay, x plus y equals 4. Anybody tell me how to graph that? Seriously? Well, what are the intercepts? If you put a 0 in for x, you get a, if you put a 0 in for y, you get a, okay. So we had crosses at 4 here, 4 here. Is it above or below? Below. So we're talking about this little tiny area. All right. These two just mean we're in the first quadrant, so we're bounded by this line and this line. All right. What about this guy? Can I do intercepts? Is that okay? Put in the x is 0. It'll say 3y equals 6, which would be 2. Put in y is 0, and it'll just say x equals 6, right? Over 0 up 2. Over 6 and up 0. Above or below? Below. Okay. I did a kind of crummy job, but I think the corners are what? Can anybody tell me? I can tell what 3 of them are. This one is over 0 up 2, over 0 up 0. This one is 4, 0, and then I need this point where they intersect, right? Yeah, I think in yours it's 3-1 because you probably did a better job of graphing than I did. I'm going to use substitution real quick to show how I could find that. This equation would say x equals 4 minus y, right? If I rearranged it. So I'm going to put that in here. 4 minus y plus 3y equals 6. If I subtract 4 and add the common terms, I'll have this. So I get y is 1. I plug it back in right here, and I'll have x is 3. So this was 3-1. Yours was, I'm sure, more accurate than mine, and you could tell it was 3-1. All right. Are we done?
Oh, wait, no.
We have to take those 4 ordered pairs and plug each of them into what? Yes, x plus 2y. All right. Called the objective function. What is x plus 2y going to give us for 0, 2? You can do it any order. I just wrote them down in this order. I would get 4. 3, 1 would be 5. 0, 0 would be 0. And 4, 0 will be 4. So the max is 5. And that occurs at, that's supposed to be an at, sorry, 3, 1. The worst at ever drawn. And a minimum of 0, which occurs at 0, 0. See, I can draw an at. All right, good. Okay, now we're going to do some applications of this. Seem okay? All right, it says a leather company wants to add belts and wallets to its current production line. Belts require 2 hours of cutting time and 6 hours of sewing time. Wallets require 3 hours of cutting time and 3 hours of sewing time. The cutting machine is available 12 hours a week. Okay. This is where I start to go, okay, this is like the most we can use that machine, right? So at some point, something's going to have to stay under 12. And the sewing machine is available 18 hours a week. So the sewing machine is going to have to stay under 18. Belts will net us $18 in profit and wallets $12 in profit. How much of each product should be achieved to produce to achieve maximum profit? There's a lot of numbers in that problem and a lot of words. Okay. Big thing. What are we making? Okay. So we want to say X is the number of belts and Y is the number of wallets. Now, the next thing I always do is I do the objective function because then I'm done with those numbers and I can cross them off and they're not confusing me when I do the rest of the problem. Okay. What is the profit that we make down here? $18 for every what? Belt. Yes. So that would be 18 per X. And wallets, we get a profit of 12. So plus what? 12Y. Okay. Like I said, I like to do that early on in the problem just because then those numbers aren't confusing me when I go to write any other functions. Okay. We can't make negative items, so we have these 2 hidden constraints here. Now it says cutting time. We only have 12 hours of cutting machine time available. Well, what do we know about cutting? You're used to saying belts require 2 hours of cutting and 6 hours of sewing, so you want to do like 2x plus 6y. But that's not what's happening because this machine that does cutting has to cut both things. So belts require how much cutting? 2 hours of cutting, so that's 2 per belt. Plus, what about wallets though? 3 hours of cutting, so 3y. So again, that was cutting for from one sentence and cutting from the other sentence. That's where it gets a little confusing. All right, then if we have the sewing time. Every time we make a belt, which is X, it takes how much time to sew it? And how much time to sew the wallet? Okay. Everybody okay? Got those down? Are they already done on your paper? I don't know. All right, now I need to graph those. I'm gonna need somebody. Oh, is that done on your paper for you? Okay. Well, they graphed them. The easy points to find are always the corners that are on the x-axis or y-axis. How did they find this one? Because that's not a nice point. It has to be where these two intersect, right? Could we just change the signs on one real fast and then the y's would drop out? I don't think I'd bother to even type this in my calculator. If I add those together, what do I get, guys? 4x equals 30. If I divide that, I get 7.5. And then I'd have to plug it back in here. This would become negative 15. If I add it over there, I get 2. I subtract it over there. I get negative 3. I divide and get 1. Is that what that was? That wasn't right, is it? What did I do? Oh, thank you. Yep, messed up from the beginning. Like, yeah, it wasn't even 7.5. Okay, now if I add them, I get 4x equals 6. What? That's 1.5, right? 6 divided by 4? Okay, I'll be all right here in a minute. If I put a 1.5 back in, 2 times 1.5 is 3, so I'd have negative 3. If I add it over here, I have negative 9. I divide and I get positive 3. All right, maybe a matrix would have been a good idea for Hofbauer since he can't solve. Okay, anyway, that's how they got that point. Now, these are the corners. This is the profits. They plugged them all in. They found the maximum profit was here, $63. If they make 1.5 belts and 3 wallets a week. That is a really weird number, but could they leave a half a belt done and finish it the next week? So they're just trying to maximize the use of their machines. All right, it's also possible, guys, for the system to have multiple solutions, and we did actually that one had multiple solutions about the cookies, right? But on the quiz, it's not going to have that, so I'm not going to spend too much time on this. So we're going to go through this one super fast. They graphed all the lines. Can you tell me what these other points are? What's this one right here? 0, 4. This one would be 0, 0. And this one would be 3, 0. And then they found these two nicely for us. Okay, so if the objective constraint was here, we'd have to plug them all in. So 6 times 0 plus 3 times 0 would be 0. 6 times 2 plus 3 times 4 would be 24. Did I do that right? 18, 12, and then this would be 18 plus 6 would be 24. So both of these 2, 3, 2, and 2, 4 work. So anything actually on that line would work. So they found the equation of the line. But you're not going to have to find the equation of the line. All right. We're going to try this one quick. Which is the objective function here, guys? Yeah, this f of xy, that's what we're going to check out at the end. And it says we want both the maximum and minimum values. The rest of this is all graphing. All right, what can you tell me? We'll start at the bottom. X has to be greater than 0 means it's above that, right? Okay. Y is less than 5. Or X is less than 5. Woo. Means what? Yes. And it's got to be to the left of that line. Okay. And above this line. All right. y is greater than 0 means to the right of the y-axis, okay? What about this guy? Y is less than or equal to 5. Horizontal line and below. So right now we have a square, a rectangle, something here, right? I think it's a square, isn't it? Now, how do we do this last guy? Okay, we could. It's pretty easy to get the y by itself. Could we just move the 2x over to the other side? Yep. Start up at 11, down 2 and over 1, down 2 and over 1, down 2 and over 1. Do I need to be above or below that line? It says less than. Okay. So there's my final area. When you have a horizontal or vertical line, you know something about all the points on that line, right? So to find these intersection points, to find this one right here, I know that y equals 5 on this black line right here. So if I put a 5 in here, I get negative 16 equals negative 2x, negative 6, wow. Divided by negative 2 is 3. So I got 3, 5 for this point up here. This point down here had what x value? Yeah, x is 5 on that line. So if I go back and I put x equals 5 in up here, I'll have y equals negative 2 times 5 plus 11, which would be what? So I have 5, 1. Does that look right on your paper? And what are the other corner points? Careful you don't miss any. 0, 0, okay, and is where this black line crosses, does that count as one of the corner points? No, because it only goes out this far, so that's 5, 0, and up here was 0, 5. And is that all of them then? Counting this green one here and this purple one, right? Okay, that's a lot of them to check. Can I not rewrite them? Would that be all right? If I put this one in to here, 2 times 3 plus 5 would be 11. I'll just write it next to it and circle it. What if I put 0, 5 in here? I just get 5, right? If I put 0, 0 back in there, I get 0. If I put 5, 0, I get what though? 10. And 5, 1? 2 times 5 plus 1 would be 11. Okay? So all of the points from here to here actually work. And that's all I'm going to say about it for now, because we're not going to have one with 2 solutions on the quiz. Okay? Skating. This time we are a manufacturer making roller skates and ice skates. Okay. Write an objective function about profit. What is the profit? What are we making again? Roller and ice. So what do we make for profit, guys? Okay, everybody good? What do we know? Can we have negative of anything? No. So we can't have negatives. And what other 2 constraints do we have? Every time we need to assemble them, we have a maximum of 200 minutes available. So we have to stay less than 200 minutes of assembly. Well, how long does it take to make roller skates? 5, and ice takes 4. All right. And then we have to stay less than 120 for checking and packaging. And it takes only a minute to double check and pack roller skates. But apparently we have to be very careful when we do the ice skates, so it takes 4 minutes. We're gonna cut ourselves on the blades or something, I don't know. Okay, so it's gotta be in the first quadrant. What am I graphing? Do I graph this black one? No, only the green ones, okay? If I put a 0 in for X on this, I would have 50 for Y. If I'm going kind of fast here, I know. If I put a 0 in here, I'd have 5 into 200 would be 40. So over 0 up 50, over 40 up 0, there's one line. The other one, if I put a 0 in for X, 120 divided by 4 would be 30. If I put the 0 in for Y, it would just say X equals 120, which isn't going to fit on our paper. So over 0 and up 30 is a boundary, and then it's going way up there somewhere to 120. How could I find the points of intersection real fast? Guys, do they both have a 4y? Okay, so I'm going to rewrite that one down here. X minus negative X minus 4y minus equals negative 120. And then I'm going to add them together real quick because I don't want to take time to do it on my calculator. I get 4x equals 80, so that makes x 20. If I plug 20 back in over here, it'll say 20 plus 4y equals 120. 4y equals 100. Y is 25. So does it look on your paper like it could be 2025? Whoops. 2025. All right, so the boundaries are 2025 and what else? 0, 0, 0, 50, and 30, 0, not 40, 0, right? Can't go out that far. Okay. So here's our profit, 30x plus 40y. I don't think we're going to maximize the profit at 0, 0, do you? No. That would be 0 profit. Okay. If we put in 0, 50 into here, I'm talking about this equation now. 0, 50 would be $200. 30, 0 would be 30 times 30 would be 900. Did I do that right? No, $2,000. And this one is 900, right? 30 times 30. Okay. And then somebody do this guy. 30 times 20, 6,600. Plus 40 times 25 would be maybe 1,000. Is this 1,600? Thank you. All right. So how many roller skates and ice skates should we manufacture to maximize profit, and what is our maximum profit? So max of how much? If we make what? Yeah, we make only 50 ice skates. So that's a great example to show you that it's not always at that intersection point you had to find, okay? Anytime you change the profit equation, you're going to change where it is. All right. Merry Christmas. Happy New Year. I'm going to cut the assignment. See how it says up there to do on page 410, 9, 12, and 29? Okay, 3 book problems. I'm still going to leave those 3. That's it, though. Worksheet 13, we're going to skip 2 and 3, and instead we're going to do number something together on the back. Number something. Number something. What's the something number, Hoffbauer? This one, 7 on the back. So I'm on 13B. And if we can get through this question together, then we will You won't have to do anything on 13 for homework, okay? The homework check will just be those 3 book problems. And you're going to want to use graph paper for those, FYI, that's why it's in the back of the room. Mr. Big and Ms. Small are starting a company to make remote control vacuum cleaners. They will make big vacuums and small vacuums. They have only enough materials to make at most 6 big vacuums and at most 8 small vacuums each day. It will take them 2 hours to assemble a big vacuum and 1 hour to assemble a small vacuum. They can put in at most 16 man hours a day. If they make a profit of $120 on a big vacuum and $100 on a small vacuum, how many of each do they make to maximize profit? Okay, this used to be a quiz question, but Mr. Abruzzo and I broke it down so that there's like 4 separate problems and you just have to do a little part of each one of the 4 so that you're not double whammied. But tell me, what are we making? X equals number of what? Okay. And small, right? Okay. I always do the profit so I can get that out of the way. Not worry about those numbers. Anybody know what's the profit? 120 on big, so that would be 120x, and 100 on small, so plus 100y. And now I'm done with those numbers, so I don't have to get confused with those. Okay. Who else can come up with an equation? How about this at most 16 hours business? Okay. And what is it that we're making less? It takes what? 2 hours for big and 1 hour for small? It has to be less than or equal to 16? Okay. The other 2 are kind of weird, but there are 2 of them. We only have enough materials to make at most 6 big vacuums. So that's just straight up what? X must be, yes. That's a gift, guys, right? Because that's just going to be a vertical line. Okay. At most. All right. I can't count these because I'm blind and old, but is this somewhere around 6? Yeah, very straight. X equals 6 is that line. Okay. I'm totally faking this. Up here somewhere is y equals 8. So we're down to this little area because it has to be greater than 0. Now I have 1 line left to cut through there, and that's this guy, which would graph as y equals negative 2x plus 16. So if 16 is the top and I'm going down 2 and over 1, does it cross the, anybody accurately graph that? I'm going with it looks like that. It's probably not what it looks like exactly. But tell me some of the corners. 0, 0, yay, no one's getting that wrong on the quiz, are they? What's this one right here? It says right there y is 8, so it's what? 0, 8. What's this one right here? It says x is 6, so that's 6, 0. Okay, on the green line, if I put in x equals 6 right here, what will I get? Right there, the blue line has to have an x of 6. If I put the 6 in there, guys, what's negative 12 plus 16? 4? Okay, what's true about this line over here, this blue line going across? Y is 8, so the y coordinate has to be 8. I'm going to put it in here. If y is 8, I subtract 8 from both sides and get 2x equals 8. So this is 4. Is that looking like yours, guys? Did anybody graph it more accurately than me? Is it this shape at least? Do I have the right idea? Okay. So now we need to put all of those in. Okay. 0, 0 would give us a profit of 0. I think we're not going to worry about that one. 0, 8 would give us a profit of what? $100 because it's 0 and 8 in here. Okay. 60. Yep, thank you. Fix me. 800. 60 is 6 times 120, which is 720. And then we have 48, which would be 4 times 120 plus 8 times 100. 480 and 800, 1280. That was, I don't know. I didn't have enough blanks, so I was just kind of ignoring the blanks here for a minute because apparently I just left off 0, 0. I don't know. We didn't have enough blanks for sure. And what did I miss? 6, 4. So 120 times 6 plus 100 times 4. Yeah, that seems like 1120 to me. Okay, so sentence answer. Max profit of 1280. So they should make what? 4 big and 8 small. I don't know if anybody else likes these. I kind of like these. So, all right. So a grand total of 3 homework problems tonight. I don't know. I lost the page. Here it was. Yes, right here. Okay. Guys, next week, the whole agenda is up here, okay?